So this here is an analysis of Angry Birds. We're going to start by opening up the video. Let me show you what we did. I came in here and I plotted the points. First of all, you need to set the axis. So advance the video to the starting point here where the bird is at the bottom of the catapult. And so you set the axis by clicking on it. Okay, also go to your movie options, change the advance rate to 5, and then the first VA point defines movie times 0. That way all your coordinates will be proper and your analysis will be right. Okay, and then start putting the dots. So click on this tool and you click all the dots, and I've already done that. So let me advance it frame here. And notice I did it every 5 frames, so it goes a little faster. Once you have that, we also need to get the size. Now the size here, what we're going to do is actually kind of like reverse engineering on this one. We want to know what the size of this one is, the size of the bird, in order to figure out what gravity is, but we're going to just assume gravity is 9.8 and go backwards from the analysis. So over here on the video analysis part, when we do the graph fit, this should be 4.9 in this box right here. So that's our goal here. So I'm going to change the ruler here and click on the bird, and we're going to assume that I have 0.78. Let's just change it to 0.8 and see what that does to my curve fit over here. It makes it 5.1, which is close to 4.9. So I want to go back and oops, I missed. Let's go back here. Make sure you get the whole bird, or otherwise it doesn't really work right. Okay, so I get the whole bird, and let's make it back to 0.78 or somewhere in there, and check this. So it's somewhere in between there. You just have to play with it a few times. Make sure you're actually selecting the right part of the bird. And let's try that again. Maybe it's a little 0.79. Anyway, so that's close enough for me on this one. All right, and so that's what we're going to do. When you actually set this up, you're not going to have all 4 graphs. You're going to have to insert all 4 graphs. So you go to Insert Menu, Graph, and then you just select which of these you want. You're going to want one of each. Okay, so I've already done that here. And so we got all 4 graphs set up, and then you need to do a video analysis on each one of these, the actual regression line. So for this one, you select the area and click on this tool right here for curve fit. Click on quadratic curve fit, and you're going to select the region up here near the top, and it does a curve fit. Hit the try the fit button, and it should be about 4.9 or somewhere in there. So we got 4.5 for that one, or if you select a bigger region, you might get something a little different. Try fit 4.6, it's a little closer. When I did mine, I got 4.7 over here, so that's good. Again, that should be half of gravity. Gravity is 9.8, okay? And that's dependent on the size of the bird. So the size of the bird really does matter, and that's what we're trying to find. 0.78 is a pretty big bird, but that's an angry bird. They're not real birds. So anyways, over here, once you have the Y set, you want to do it for the X graph as well. You're going to do a linear fit. You just click this button right here, the one with the little R. It automatically does a linear fit, and that gives you the slope of that line, which is important. Again, that 4.72 over here is important. You're going to do it for the X velocity and Y velocity graphs, and do linear fits for those, both of those, so you get those boxes set up, and you get these slopes here. Those two are also important. And then we got to talk about all of these different graphs here and how they relate to each other. So something, and this is open-ended, you can say pretty much anything you want, but you have to at least do some kind of analysis, and the more detail you put in it, the better, obviously. So right here, like we said, this is half of gravity. That's very important, and you need to relate it to the equation. But then you might want to grab this slope tool over here, the tangent tool, and stick it over here on this graph and actually talk about, let's try that again, slope tool, talk about the slope of this line, okay? And also notice over here, as we move this, the bird moves up and down, and so you can kind of get a visual of where the bird is at the time, okay? Notice that we have speeds here. The slope is the speed. Remember that, slope equals speed. It's also derivatives for all you calculus students. So the slope right down here at the bottom is 15. And let's go up to the next dot. It's about 13.6. Well, if you draw a vertical line straight from that point down to here, the slope of this curve equals the value of this curve. 13.63 is the value of the line right here. 13, 13, 13. If I go up here to the slope right here is about 7.7. If I follow that straight down, The slope right here, it's about 7.7. So the slope here is the value here. Why? Because this is displacement, this is velocity, and the derivative of the displacement is the velocity, or in other words, the slope of the displacement is the velocity. So we're learning calculus at the same time, so this is exciting. The slope here at the top is obviously 0 because it turns around, and then we have slopes going the other way. Notice that they are negative. They should be negative because it's going down. Okay, and also if you look at the graph here at the very top, the 0 slope is the 0 point on this graph right down here. Negative slopes over here are negative values down here on this graph. If you say all this when you record this video, you're going to get an A. Anyway, back over here, let's look at the slope of this one. Why is it always the same? Well, the velocity in the x direction is always the same. It does not change. There's no acceleration in the x direction. Acceleration is only gravity for free fall acceleration. So that's something you might want to mention. Over here, why is this line straight? Talk about the slope here. Why is it a slope that's really close to 0? You got to figure that out. Well, if you know anything about calculus, the slope of a constant number, the derivative of a constant is 0. That's why this is 0. So calculus students, good luck. Physics students, good luck. And hopefully this makes sense. You also might want to add a few other things in here, and I'll get right back to you. So another thing you might want to mention is the fact that right here again, the slope is, oh, let's hit the slope tool. Okay, the slope right here is the 6.2. If you're finding the slope through here, this entire line. Again, the slope there's the value here. See how it's above 6 and it's about at 6.2 if you look at this. But the slope here is 0 because there's 0 acceleration in the x direction. Okay, but I want you to notice specifically that the velocity in the x direction, we have an equation that says v sub x equals vi cosine theta. Okay, so what does that mean? This is vx. This is not vi cosine, or I mean, it's not vi. But if you know the theta over here, if we actually measure the angle theta, and you can do that for extra points here, if you actually measure this angle, you could figure out what the initial velocity is for this entire experiment, not just Vx. This is Vx. This is Vy over here, okay? These are velocities in the x direction, velocities in the y direction. But this, we want to find Vi, not just Vx and Vy. So you can find Vi by taking Vx here, this 6.2, and dividing it by the cosine of theta. Well, you got to find theta by measuring that angle right there. It's the angle from this line all the way down to this yellow line. So you can find theta real quick right there. And you just use a protractor, print this page out, find the angle, and boom, you got VI. So that's something else you could do. Now, if you notice, I also put the data down here at the bottom. This is for all you number crunching type of people. I prefer graphs myself, but if you like to just look at the graphs or the data itself, you could come in here and see when I drew these dots here, these numbers actually were stuck into the table. So you could go through here and like look at the y velocity one right here. Again, on the graph, it's positive, hits 0 and goes down to negative. Same thing here. Starts at positive 13, goes through 0 right here, and then it goes down to negative. And again, that 13.6, where's that? Well, that's way up here at the top, 13.6, but that's the slope right here, 13.6. Look right there, slope. Oops. When I hover over this blue dot, what does the slope say? It says 13.631. That's the slope here. That's the value here. Slope equals the value of this one. Anyway, have fun. Try to figure out as much as you can, and good luck. This is a little fun experiment. And then once you finish all this, you need to do this analysis for at least 2 different parabolas. You're going to take this video, you're going to upload it to YouTube under the RHP Physics username. And then once you do that, and you make 2 of these and do the analysis on 2 of these, you're free to play Angry Birds and have a wonderful day. Thank you. Bye.